Hello.
Hi, everyone.
I am Astrobit,
I am Major Merger.
and it is time for Astronomy in the News. What month are we in? July?
July.
2017. Okay, actually, before we get into our actual slides, we've got a very special Astronomy in the News event happening tonight. It is our own notorious LAE, Steve Finkelstein's birthday. So we're going to lead off with a happy birthday song for him.
Please, everyone, join. I don't want to be the only one singing up here.
You don't want to hear me sing. All right, on three. One. Coming up, Steve. 1, 2, 3.
Happy birthday
to you. Happy birthday to you. Happy birthday, dear Steve. Happy birthday to you.
Is that dangerous?
I'll get electrocuted up here.
Yeah, okay.
All right.
Worth it.
Okay, first up on the news this month, former astronaut Julie Payette has been announced as the next Governor General of Canada.
Fun fact. Brian had a huge crush on her when he was younger.
I did. Still do. Similar to the president, in the absence of the Queen, the Governor General acts as the head of state of Canada and is also the Commander-in-Chief of the Canadian Armed Forces. Ms. Payette holds a Master of Applied Science in Computer Engineering from the Massey College in Toronto. She was selected by the Canadian Space Agency as an astronaut in 1992 and has flown on the Space Shuttle twice. The first time in 1999 as a mission specialist on Discovery, and the second as a flight engineer and lead robotic operator on Endeavour on STS-127. Both missions were ISS assembly flights. She will become the fourth woman to serve as Governor General when her term begins this fall.
I wonder what it's like to have qualified people in positions of power in government.
Crazy. It's so crazy.
All right, moving on. So a research team has conducted a 3D map of a supernova remnant from a star that exploded 3 decades ago in 1987 in the Large Magellanic Cloud. So thanks to observations from the Atacama Large Millimeter Array, or ALMA, in Chile, astronomers can now see through the large amounts of dust that were created in the initial explosion to reveal the structure of the remnant underneath. So on the left here, the red shows the newly formed dust in the center. Green and blue show where the expanding shock wave created by the explosion is colliding with material around the supernova. And then the green visible light is seen with Hubble, and blue is the hottest gas that's observed with the Chandra X-ray telescope. So scientists then took that initial image and mapped out the abundances of different molecules that formed in the aftermath of the supernova. So then on the right, we have purple in the middle indicating emissions from silicon oxide, and yellow is emission from carbon monoxide. And then the blue ring around is the same as the Hubble data, the Hubble visible data, but just expanded into 3D. So this was a type 2 supernova, which is when a star that's at least around 10 times the mass of the sun runs out of fuel to burn, collapses in on itself, becomes gravitationally unstable, and then explodes back out into a supernova. Yeah.
All right. Speaking of future supernovas, a team led by Eamon O'Gorman, a research fellow at the Dublin Institute for Advanced Studies. By the way, I tried to figure out the Irish pronunciation of that, and I just gave up. He used the ALMA radio telescope array to image the star Betelgeuse, which is a well-known massive star that's visible in the constellation Orion, seen on the left here. Betelgeuse is a red supergiant. It's expected to go supernova sometime in the next 100,000 to million years. Tomorrow, in astronomical terms. Actually, literally could happen tomorrow. It's so massive, being so massive and only being about 650 million or 650 light years away from the sun, Betelgeuse was the first star besides the sun to actually be resolved, to actually like take a picture and be able to see from one side of the star to the other. And that happened in 1920. The most recent imaging of Betelgeuse used microwave emission, so it allowed the researchers to probe just below the star's visible surface. The study revealed that the temperature below the surface is less than the temperature at the surface, which is very unexpected. So below the surface, about 500,000 kilometers below the surface, it's about 2,700 Kelvin, and at the surface, it's about 3,700 Kelvin. This is the opposite of what's expected. We generally expect stars to be really hot in the center and cooler out at the outer edges. The study also confirmed previous suggestions that the star is misshapen, which you can see in the center image here. It kind of looks a little elongated off on the left side. There's also a bright spot kind of on the top left. These hot spots are thought to be a result of heating of the gas due to strong magnetic fields. It's also notable, my advisor, Craig Wheeler, here at the University of Texas, recently published a study on the star suggesting that it might have swallowed a smaller companion probably within the last million years or so. So it's possible that some of those weird blobs could be associated with that.
Okay, well, some of you might have seen this, and this is just a shout out to all the citizen scientists in the world. I know from the last talk we have a few, at least, in the audience tonight. So new images of Jupiter's famous Great Red Spot have been released. But the cool thing about these, and there's more than just these two, but these are the two I chose. But they were created by citizen scientists. So initially the images were taken by JunoCam, the instrument on board NASA's Juno probe. And on July 10th, the probe captured the giant storm, whose diameter for reference is larger than the Earth's diameter. The whole Earth could fit inside of that spot. But then citizen scientists have taken the images and processed them in different ways to enhance and highlight the different features to give you these super cool images you see here. So NASA's Director of Planetary Science, Jim Green, says these images are the perfect storm of art and science. And Jason Major, shown down here on the left, is one of these citizen scientists. He created the image on the left. And Sean Doran, who I don't have a picture of, created the image on the right. So Jason, just for reference, is a graphic designer from Rhode Island, and it just goes to show you that anyone can be involved in astronomy without, doing what we do and get a PhD. And
no need to waste 6 years of your life.
Yeah, you can go do fun stuff and still be involved. Yeah.
All right. Karishma Bansal, a graduate student at the University of New Mexico in Albuquerque, used the Very Long Baseline Array to measure the motion of two supermassive black holes in the center of a galaxy known as 0409 plus 379. Very exciting name. The galaxy lies about 700 million light years from Earth. The black holes, which are shown in the picture here, labeled C1 and C2. This is a radio image, so this is pseudo color showing how bright it is in radio. It's one of the few pairs of binary black holes that in which we can actually see both black holes. The team used measurements of the black holes dating back to 2003 to determine the motion of the black holes, and were able to measure a total motion of about 10 microarcseconds. In practical terms, this is the equivalent of seeing something move on the moon by 2 inches. In this galaxy, the motion corresponds to one of the black holes moving about 1/10 of a light year, or 1 trillion kilometers. There's not enough information yet, there's not enough time gone by to fully determine the orbits of the black holes, but the team estimates that the orbit takes on the order of 28,000 years. And they've also measured a mass of the black holes of, I think it was about 16 billion times the mass of our sun. This research is exciting that it opens up new opportunities to measure the orbits of black holes, or even, potentially look at these black holes in the centers of distant galaxies.
All right, now it's time for our new segment, Astronomy Not in the News. So these are stories that may not have reached the general public, but are things that astronomers are talking about a lot in universities and labs and observatories and the such. So this month, we're talking about more about black holes. So many of you might have heard, thanks to LIGO and Virgo, we have direct evidence of gravitational waves produced by merging black holes. So the authors of a recent paper, though, want to know how common it is for these events to occur, and how, in particular, stellar mass black hole binary systems involve inside nuclear star clusters located in the cores of galaxies. So you have your galaxy, near the center, you have star clusters, and then you have binary systems, so two stellar mass black holes, so like 10 to 30 times the size of the sun, in orbit with each other. So they want to know how they evolve and how common they are, and in particular how they're affected by the supermassive black hole that resides in the very center of the galaxy. So this is a kind of an interesting setup when you think about how those three bodies can interact with each other. And so due to the presence of the supermassive black hole, the two stellar mass black holes that are in that binary orbit can undergo eccentric Kozai-Lidov oscillations. And I apologize if I butchered those names. So this affects the orbit of the binary system, causing the stellar mass black holes to have an extremely close encounter that they wouldn't have normally in their stable binary orbit, which can cause the stellar mass, so they'll have a close encounter, which will result in energy loss through gravitational waves, and then finally they can merge together. So the authors of this paper conclude that this eccentric Kozai-Lidov effect makes black hole mergers more efficient, with a supermassive black hole present to torque their orbits in that way. And so they conclude that they occur at a rate of around 1 to 3 per cubic gigaparsec per year. So that's still pretty rare, but still pretty cool. So while this is still fairly uncertain, it shows that stellar mass black hole mergers in nuclear star clusters may actually make up a large portion of the black hole mergers detected. And there's a plot from the paper in case you're interested what plots from astronomical papers look like. No.
All right. That is all we've got for Astronomy in the News for July 2017. Thank you all for coming, and enjoy the rest of the show.
Thank you.